Hi, this is a continuation of today's lesson on parabolas and the quadratic form. Now, we were looking at this earlier today. The general form for a parabolic equation or a parabola is y equals ax squared plus bx plus c. We know that the x-intercepts occur when y is 0. Now, x-intercepts are also referred to as the root of an equation. So when you want to work out the x-intercepts, you put y equals 0 there, and you get 0 equals ax squared plus bx plus c. Now, if the equation that you get there looks like it can be factorized, then you should solve the equation by factorizing it. In the last lesson, lesson 4, we solved sometimes if you can't factorize it, you can complete the square, which is what we did in lesson 4. I think we factorized in lesson 3. So in lesson 3, we factorized. An example where you might factorize if you have something like this. X squared, let's say, plus 6x plus 5. We know here that we can factorize that because the factors would be x plus 5, x plus 1. Completing the square, you might start with your equation y equals x squared plus 2x plus 7. Obviously, we cannot find factors of 7 that add up to 2, so in this case, you might complete the square. Also with this case, y equals x squared plus 2x plus 7, if you don't like completing the square, your other option is to use the quadratic formula. Now, you have used the quadratic equation before, so it's just the quadratic formula, and we're just going to review that. So, the quadratic formula will give you the solutions or the roots of that type of equation. For example, you might have 0 equals let's say 3x squared plus x minus 7, okay? So you might have this equation here and you can't factorize it. You can't think of factors of minus, this one's a little bit tricky as well because of the 3 here. So you might decide you would use the quadratic formula for a question like this. In this question, of course, a is the coefficient of x squared, which is 3. B is the coefficient of the x, which is 1. And c, sorry, I'll just fix that, and c would be the coefficient of, not the coefficient, but the constant term. And this is the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, now, we're not going to prove that formula. So here is this formula. You need to know that. However, you will be provided a formula sheet anyway in the exams coming up. So for example, here is an example down here. And it says, what are the x-intercepts of y equals x squared plus 3x minus 6? Now, if you can't factorize it, you look at it and you say, I can't factorize that easily. So you use the quadratic formula because we cannot think of two numbers that multiply to give negative 6 but add up to give 3. I mean, negative 6 you could have 5 and 1. Look, one of those could be negative, one could be positive. I'm not saying which one. But to try to get 3x, you might do it that way. That doesn't work. Negative 6 has got factors 3 and 2. You know, one of those would be negative, one would be positive. It wouldn't matter which one, but there's no way we can end up with 3x there. So here we've got this here, y equals x squared plus 3x minus 6. And we can see the coefficient of the x squared is 1, so a is 1, b is 3, and c is negative 6. I'll just pause the video for a sec. And now I'm just going to continue this question. I know it's done over the page, but I'll just do it down here. So if we can't factorize this, we've got x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And that's negative 3 plus or minus the square root of 3 squared minus 4. Sorry, I'm off screen. So it's negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 6, because I'm doing b squared, that's 3 squared minus 4 times a is 1 and c is negative 6 over 2 times a is 2 times 1. And I get negative 3 plus or minus the square root of. Now you get 3 squared is 9, minus 4 times 1 is negative 4 times negative 6, you get plus 24 over 2. So therefore, we get that x equals negative 3 plus or minus the square root of 24 and 9 is 33 over 2. Now that can't be simplified. So therefore, these are the solutions for x. It's not a rational number. Like it can't be written our solutions for x aren't whole numbers or fractions, and they're actually surds, which is why we couldn't factorize that easily. So that's when we use the quadratic formula to find the x-intercepts. So as you can see over here, it's just done here, and I just stopped here, -3 plus or minus square root of 33 on 2. So therefore you do have two solutions, -3 plus root 33 on 2, so that's the first solution, and the second one is -3 minus root 33 on 2. Now you could use your calculator if you wanted and get approximations to that, and they actually have them here. So this, if you did that on your calculator, you'd get approximately 1.37 for that one. And this one here, you get minus 4.37, okay? Now, how many x-intercepts? Now, if you look at how we just use this quadratic formula, and what we're looking now is at just the b squared minus 4ac bit here. Now, the value of this b squared minus 4ac actually tells you, it actually has a special name, sorry, and it's called the discriminant. And it actually is really important because it will tell you how many answers you will get here when you use your quadratic equation. Now, there is a special symbol for the discriminant, and it's like a triangle. So this is the discriminant symbol, triangle, like that, equals b squared minus 4ac. Now, we're going to look at our hot sheet in a minute, and we're going to look at we're going to explore the effects of this discriminant on the number and type of x-intercepts, okay? So just going to this sheet here that says examining the discriminant, parabolas and quadratic formula, okay? With this first one, I'm going to, that's actually the sketch of this. You can see obviously that the y-intercept would be -7. It's concave up, so this is actually what this parabola looks like. You're not expected to know that straight away, but I'm going to look at the discriminant, b squared minus 4ac. Now that is 5 squared minus 4 times 1 times -7, and we get 25 plus 28, which is 53. Okay, now what I want you to do, I'll just do this one as well. So the discriminant is b squared minus 4ac, and when you do it, just notice here, sorry, I should have written down here that a is 1, for example, for this one, a is 1, if you look here, so I can't see that very well, b is 5, that's the discriminant, and c is -7. It's probably not a bad idea to write down what each of the things are. Here a is -3, b is -2, c is 0. So when we're working out the discriminant here, we get b squared is -2 squared minus 4 times -3 times 0. And we get -2 squared is 4 minus 4 times -3 times 0. That'll be just 0. So the discriminant here is 4. Okay? And also the parabola is concave down. We can see that the y-intercept is 0, which is why it cuts through there. Okay? Now, what I want you to do now, I'm going to pause the video, okay, and I want you to work out the rest of this page, okay? So I need you to do all those and work out the discriminant for each of them, okay? When I turn the video back on, all the solutions will be here, okay? Or when you turn it back on. So I've actually just done C, I got 100. Just with this one, just be very careful, because in this case, A is 4 and B is the coefficient of the X, which is 0, and C is -5. So just be very careful with that one when you do that, okay? I'm going to pause the video again. You can keep going. I know we haven't finished yet, so what you'll notice in question 1 is that the parabola cuts the x-axis twice. There are 2 x-intercepts, okay? And just notice that the discriminant for all of these is positive. So in part 1, parabola cuts the x-axis twice and all of the discriminants are positive. Okay, now keep going with question 2. You'll just notice with the first one that the parabola does not cut the x-axis at all. This is the x-axis, that's the y-axis. We can see that the y-intercept is 7, but it doesn't cut the x-axis. Notice that the discriminant was -3, okay? So keep going with question 2. And just looking at question 2, with our first answer, our discriminant was -3. Notice the graph doesn't cut the x-axis. In our second one, part B, the discriminant's -56. Also note here it's concave up, so it's got to be upwards but not cutting the x-axis, and the y-intercept's 7. Okay, here it's concave down, so it's downwards. Discriminant's negative, so it doesn't cut the x-axis. Okay, So it must be like that. And also the y-intercept here is -5. If you put x is 0, you get y is -5. Here, notice that the discriminant is negative again, and it's concave down, so it's downwards. Also, y-intercept's -21. Look, the main thing here is that when we work out the discriminant, which is the b squared minus 4ac sign, if you get a negative answer, I'll explain exactly why this is happening in a minute. The graph does not cut the x-axis. With this last one, just be careful. A is 4, but b again is 0, and c is 5. It's concave up. B squared minus 4ac is 0 squared minus 4 times 4 times 5. So we get -80. So the discriminant's negative. Notice the graph does not cut the x-axis. So far, if the discriminant's positive, looking at these values here, the graph cuts the x-axis twice. If the discriminant is negative, the graph does not have any x-intercepts. In other words, it does not cut the x-axis at all. Okay? Now we're going to look if the graph just touches the x-axis. So with this one, discriminant is b squared minus 4ac, so it's 6 squared minus 4 times 1 times 9. So that's 36 minus 36, which is 0. So when the discriminant's 0, it looks like your graph just cuts the x-axis once. Now if I factorize that, you can see that's a perfect square. It's x plus 3 squared. This value is actually -3. Okay? And in this last one, discriminant is b squared minus 4ac, which is 20 squared minus 4 times -4 times -25. We get 400 minus, now that's 400 again, which is 0. Again, the discriminant 0, and if I actually draw that parabola, you can't see it properly there, but it looks like that, okay? So it's concave down as well, because of the -4x squared. Discriminant 0, so it cuts the x-axis only in one spot. Now it says in the examples above, compare the value of the discriminant to the sketch for each parabola and comment how the discriminant can be used to determine the number of x-intercepts. So if b squared minus 4ac is greater than 0, there are 2 x-intercepts. So that gives us 2 x-intercepts. If b squared minus 4ac is negative or less than 0, you get 0 x-intercepts. And if b squared minus 4ac is equal to 0, that gives you 1 x-intercept. Okay? Now I think there's more of that over the page as well. Now with this next bit, we can do the discriminant for each of these. Now it says each of these parabolas, these parabolas here could be factorized, okay? So when you can factorize a parabola, you'll notice something very special about the discriminant, okay? So I'm going to, just going to show you that what I'm going to do, I'm going to factorize them just to show that you can. Factors of -12 that add up to -4 would be -6 and +2. So notice that the x-intercepts, if you had to work them out, x is 6 or -2. But I'm just going to work out the discriminant. Now it's b squared minus 4ac, which is -4 squared minus 4 times 1 times -12, which happens to be 16 plus 48, which is, that's 16 plus 48 is 64. Now notice that 64 happens to be 8 squared, okay? With this next one, look, I'm going to put 0 equals, just trying to work out the x-intercepts. I'm going to factorize, and obviously x is 0, or x is, if you work that out, -2/3. Notice that my solutions to this are rational. Rational numbers are numbers that can be written as fractions. Okay, now that includes whole numbers and fractions and negative numbers and things like that. Now if I work out the discriminant here, b squared minus 4ac, I get, now be careful, b here is -2, so it's -2 squared minus 4 times, a is -3 and c is 0, so that wipes that out. And our answer is 4. Now notice that 4 happens to be 2 squared. And in this last one, this could be factorized as well if we wanted. Notice I'm pulling out the negative to make factorizing easier. We did see this equation before. So if I were to describe this parabola, I'd say concave down. I'd take out the negative to try and factorize it, and then I'd factorize it and I'd get my solutions. X is -7 and X is 3 there, my solutions to the X-intercepts. But if I actually just look at the discriminant here, I get -4 squared minus 4 times -1 times 21, and that is 16 plus 84, which is 100, which happens to be 10 squared. Now, notice that if you can factorize these quadratics, so if you can factorize the quadratics and thus the roots are rational. See, if you can factorize the quadratic, the roots are rational, then the discriminant, it's greater than 0 in all these cases. The discriminant will be greater than 0, of course, but it will be a perfect square number. So notice that this one's 64, which is 8 squared. This one's 2 squared, which is 4, and this one's 10 squared, which is 100. So the discriminant will be a perfect square number, of course, and positive, because it can't be negative and be a square number. So if you work out the discriminant and you get a nice square number such as 4, which is 2 squared, 9, which is 3 squared, 16, which is 4 squared, etc., 25, which is 5 squared, you can always go back and you'll realize that you can actually factorize the quadratic. Now, in task 3 here, using the discriminant, it says find the discriminant for each of these. You can try this on your own, and thereby determine the number of X-intercepts and their nature, whether they're rational or irrational. Now, I'm going to pause. You can pause the video. I want you to complete this and then turn the video back on when you're done. So remembering that discriminant is minus b squared, sorry, not minus b squared, b squared minus 4 times a times c, and you get, for this one, 25 plus 40, which is 65. Now that is a positive number. So we've got 2 X-intercepts. It's not a square number, so you'll have irrational. Now I'll actually do a whole question here so that you'll understand why this is happening. Okay, so I'm just going to come down to the very bottom of the page. I'm going to repeat that question, x squared minus 5x minus 10. So I'm moving down here. X squared minus 5x minus 10 equals 0. When you use the quadratic formula, negative b plus or minus the square root of b squared minus 4ac over 2a, if you just know how many answers you get for this, like if you know the value of this, if you get plus or minus the square root of a negative number, well, that has no solution, and so that's why you have no X-intercepts, okay? If you get a nice, if you get a number under here like 65, like what we just got for this one, so I'll just do it now, -5 plus or minus the square root of b squared is -5 squared minus 4 times 1 times -10 over 2 times 1, and you get 5 plus or minus the square root of, I think we just did this, we've got 25 plus 40 is 65 over 2. Well, they're my roots. 5 plus root 65 over 2, comma, 5 minus root 65 over 2. These are not nice, well, they're not horrible, but they're surds. They're not whole numbers, they're not rational numbers, and that's why my X-intercepts here are irrational, because they're in the form of surds. So it depends what you get under this square root sign. If you get a nice squared number like 64, you'll end up doing the square root of 64 is 8, and you'll get, you know, negative like 5 plus or minus 8 over 2 and stuff like that, so it will work out quite nicely. Okay, but if you get a negative under this square root sign, there's no solution because you can't take the square root of negative, and there'll be no X-intercepts. And if you get 0 under here, for the b squared minus 4ac, you'll wipe out, you'll have negative b plus or minus 0, so you'll just have negative b over something, and that's why you've just got the one root. So looking at these, again, discriminant, b squared minus 4ac is -5 squared minus 4 times 1 times 10. Now, the only difference is this is a plus 10, that's a minus 10, and you get 25 minus 40, which is -15. So in other words, the bit under the square root sign will be negative, so you'll have no x-intercepts. And because there's none, they won't be rational or irrational. That doesn't apply. Okay? This one, b squared minus 4ac, is negative 10 squared minus 4 times 1 times negative 39, which is 100 plus, now 39 times 4 is 40 times, it's 156. So the answer to this is 256. Now 256 happens to be 16 squared. Now, what that means, if you get a nice square number here, it means you've got two x-intercepts because it's positive. That's why you've got two x-intercepts. But the roots will be rational. Now let's just have a look. It means that we can factorize this. The factors of minus 39 that add up to 10 would be x minus 13, x plus 10. So therefore, oh no, I don't think they are actually. X minus 13, x plus 3, sorry. That's better. So therefore, because that can be factorized, that's why you've got that nice square number here for your discriminant, okay? Looking at the next one here, b squared minus 4ac is 9 squared minus 4 times 2 times 5, which is 81 minus 40, which is 41. Now that's positive, so we've definitely got, sorry, off screen, two x-intercepts. Now that's under the square root sign, so square root of 41, that's irrational, okay? The next one, b squared minus 4ac, is negative 26 squared minus 4 times 1 times 169. Really need a calculator here, don't have one. I think 16 squared is, oh no, need a calculator for that, one sec. This one we get 14, so we've got two x-intercepts and they're irrational. You can just do that one on your own. Okay, now, I'm just going to leave this last question here. Okay, we need to go over to the next page. Formula for the axis of symmetry of an equation. We're not going to do the proof, but if you want to just quickly work out the axis of symmetry of an equation, it's x equals negative b on 2a, and you use that from your equation ax squared plus bx plus c. So if you've got y equals ax squared plus bx plus c, one way of working out your axis of symmetry is to work out your x-intercepts and average them. The other way is just to use this formula straight away, and I like to abbreviate axis of symmetry with AOS. So therefore, axis of symmetry is x equals minus b on 2a. Okay, I'm not going to go through the proof. Okay, that question on the page before that I wasn't going to do. I just got my calculator now, so just finishing it off. We get 676 minus 676 is 0, so therefore there will only be one x-intercept because the discriminant's 0, and your answer will be rational. Okay, so if you've only got one x-intercept, the answer will also be rational. Okay, so I forgot to mention that before. Okay, now if we get one x-intercept, you should be able to factorize this. So let's have a look. Factors of 169 that add up to negative 26 would be minus 13 and minus 13. So this is x minus 13 squared, which is just a concave up parabola shifted 13 units across to the right. So that's what that parabola looks like, which is why it has one x-intercept and a discriminant of 0. Okay, so if I was to come back to the quadratic formula here, because my b squared minus 4ac is 0, I'm getting 0 here, which is why I'll have negative b just over 2a, which is why I'll either end up with a fraction answer or a whole number answer. Okay? Okay, now there are a few questions. If we go to this page that I was doing in class today, sketching using the formula, what we're going to do is we're going to determine if the parabola is concave up or down. We're going to find the y-intercepts by letting x equal 0. We're going to determine the x-intercepts by letting y equal 0 and using the quadratic formula. We're going to use the formula for the axis of symmetry to determine the x value of the vertex, and then we can work out the y value by substituting into the original equation to get the coordinates of the vertex, and then we can sketch the parabola. So, okay, if you can do those, I'd like you to work out concave up or down, to do the y-intercept, then to do the x-intercepts, put y equals 0 and use the quadratic formula, and also if you could also do the axis of symmetry, okay, is x equals minus b on 2a, and then Hi girls, it's a bit quieter now. It's between lessons, or actually it's during a lesson, so no one shouting. So we'll just continue with this now. So we're still on that page, sketching using the formula. So first one, we've got question B, y equals 4x squared minus 20x plus 25. Hopefully you've had some time to do these. We can see it's concave up. Remember, we're working out the concavity, whether it's concave up or down. Then we're looking at the y-intercept by putting x is 0. Now if x is 0 here, we get 0 minus 0 plus 25. In other words, the y-intercept is 25. So y equals 25 is our y-intercept. Now for our x-intercept, we put y is 0, so we get 0 is 4x squared minus 20x plus 25. Now we're going to, look, we could factorize this and try and solve it by factorization, but we're going to solve using the quadratic formula. We're going to find the x-intercepts by using the quadratic formula, which is x is negative b plus or minus the square root of b squared minus 4ac over 2a. Look, I'm just going to have to give myself some more room here because we're just running out of room. So I'll just move this out of the way for now. And we get x is, now b is negative 20, so it's negative 20 plus or minus the square root of b squared would be negative 20 squared minus 4 times 25 over 2 times 4, which is 20 plus or minus. Now the square root of, we've got 400 minus, we've got 400 minus 400, which is 0 over 8. So here we've got 20 plus or minus 0, which is just 20 over 8. Now that's 2 and 4/8 or 2.5, so it's 2.5. Now because I got a 0 here, it meant that, you know, I could have actually easily factorized that even though I didn't. So I'm going to come back to this. So in other words, my x-intercept, there's only one and it's 2.5. If I actually do my axis of symmetry, and I will do that now, so I'm going to go axis of symmetry, AOS, is x is minus b over 2a. Now I get minus 20 over 2 times 4. So that's 20 on 8 again, which is 2.5. In other words, the axis of symmetry of that parabola is 2.5. So it appears, sorry, I haven't chosen these questions. I wouldn't have chose that example. But look, it appears that we've got one x-intercept. If I actually go and factorize that, but I am running out of a bit of room here, so I'm going to factorize that. Y equals 4x squared minus 20x plus 25. I'm taking out the 4 separately, and I'll get x squared minus 5x plus, actually that's why we don't factorize, because we've got 25 on 4, so that's not going to be nice. So I'm not going to bother with that. Actually, we did do it the right way, so let's just leave it. Let's sketch, okay? The other thing is, when x is 2.5, I'd like to work out what y is, and then I can see my vertex. So I've got concave up. I've got y-intercepts 25. There's only one x-intercept, which is 2.5, or 5 on 2, okay? So I'm going to write that as 5 over 2, because when I substitute into this, 4 times x squared, I'm going to go 4 times 5 on 2 squared minus 20 times 5 on 2 plus 25. I'm going to get, that's 25 on 4 times 4 is 25 minus, now 20 on 2 is 10, so it's minus 50 plus 25. Okay, 25 plus 25 is 50 minus 50, it's 0. Actually, that would be the case because there's only one x-intercept. So we're going to do a quick sketch now. So in other words, the vertex, so therefore our vertex is 2.5, 0. So let's have a quick sketch. We've got vertex is 2.5, 0. It's concave up. And the y-intercept, I know this is not to scale. The y-intercept's 25. Okay, can you draw it a bit steeper? Hopefully you've got a bit more room there than I've got. Okay, so that's that curve. This is 2.5, by the way, and that is 25. So just be careful there. Now with the next one, I think this one will work out nicely using the quadratic formula. So I'm just going to get rid of this because we're going to need some more room. Okay, so let's have a look. Concave up or down? It's concave up because the the coefficient of x squared is positive 1. And for y-intercept, put x is 0, and you'll get y is 0 plus 0 plus 7. In other words, it's 7, so the y-intercept is y equals 7. For x-intercept, put y is 0, and you get 0 equals x squared plus 5x plus 7. Now, this obviously cannot be factorized. So with this, we're going to do the quadratic formula. X is negative b, which is negative 5, plus or minus the square root of b squared, which is 5 squared, minus 4 times a is 1, times c is 7, over 2 times a, which is 2 times 1. So we get x is negative 5, plus or minus the square root of, now we've got 25 minus 28, which is negative 3. So therefore, that has got no solution. So that's got no solution because you cannot do the square root of negative 3. So this actually isn't, it's not a good, so there's no x-intercepts and it's concave up. So what we need to do, let's work out where our axis of symmetry is. So axis of symmetry is x equals negative b on 2a, which is negative 5 over 2 times 1. Because a is 1, remember, b is 5, and c is 7. So we get negative 5 on 2, which is negative 2.5. So negative 2.5. So when x is negative 2.5, I'm going to do this as negative 5 on 2. You have to find out what y is. So you substitute it into the equation of your parabola. Now you can just do this on your calculator. And you will get negative 5 on 2 squared is 25 on 4. Then we're going to minus, you get minus 25 on 2 and plus 7. And you get 3/4. So therefore your vertex is going to be negative 2.5, 3/4. So we've got a concave up parabola. Okay, just keeping all this separate. Okay, not much room here. Concave up parabola. Vertex negative 2.5, 3/4 up here. The y-intercept is 7, so it will put that as 7. Obviously, there are no x-intercepts, and that point there is negative 2.5, 3/4. And that's it. That's all you can sketch there. We can see from the quadratic formula that there was no solution, so therefore no x-intercepts. Okay? Here, with our discriminant, the discriminant was 0, so therefore we notice that there is only one x-intercept only. In other words, if there's only one x-intercept, it bounces off the x-axis. It doesn't cut through it. Okay? All right, now for the last question down here. All right, looking at that, is it concave up or down? Concave up. What is the y-intercept? By putting x is 0, you get negative 7. So y is negative 7 is the x-intercept. X-intercept, put y equals 0. And you want to factorize. Actually, we don't want to factorize. We're going to use the quadratic formula. So just making a bit of room down here. Right, doesn't look like one that we really want to factorize. So let's use the quadratic formula. X is negative b, so that's negative 5. See, a is 1, b is 5, c is negative 7. So it's negative 5 plus or minus the square root of b squared is 5 squared minus 4 times 3 times negative 7 over 2 times 3, so that's negative 5, plus or minus the square root of, now this is 25 minus 4 times 3 times negative 7, so it's 25, that'll be plus 84, which is 109, over 6. Now, in other words, your two x-intercepts are, x is negative 5 plus square root of 109 on 6, or x equals minus 5 minus square root of 109 on 6. If you want, you can have a rough estimation of what that would be. Look, this is a little bit bigger than 10 because square root of 10, sorry, square root of 100 is 10. Square root of 121 is 11. This is probably about 10.5. So minus 5 plus, I'm just doing it on my calculator, minus 5 plus minus 5 plus square root of 109 divided by 6, that's about 0.9 approximately, and minus 5 minus square root of 109 divided by 6 is minus 2.6. approximately. So let's have a sketch. Actually, we're not going to sketch yet. Let's work out the axis of symmetry. X equals minus b on 2a, and we get negative 5 over 2 times 3 is negative 5/6. And when x is negative 5/6, let's work out what y is. We get 3 times negative 5/6 squared plus 5 times negative 5/6 minus 7, and you will get, I'll put that down here, and you still work that on your calculator. We get 25 over 36 minus 25, actually you can just do it on your calculator. 25 over 36 times 3 minus 25 on 6. You can put it in the whole lot. I'm just doing it in a simplified form. I'm getting minus 9 and 1/12. Okay, so therefore we've got our picture of our parabola now. It's concave up. The y-intercept's negative 7. The actually I can now write down what the vertex is. It's negative 5/6, negative 9 and 1/12. So negative 5/6 is here, negative 9 and 1/12 would be roughly here. Y-intercept's negative 7, okay? So we've got negative 5/6, negative 9 and 1/12, that's my vertex, sorry. Negative 7 is my y-intercept. To see these x-intercepts, I can write them as, I'm not going to write them, I'm going to write them as what they are, as surds. And the first one, you know, the negative 5 plus square root of 109 on 6 is approximately 0.9. So this must be this one, negative 5 plus the square root of 109 over 6. And this other one here must be negative 5 minus the square root of 109 over 6, because that one's approximately negative 2.6. Okay, sorry, it is a little bit messy, but hopefully you can follow it. Okay, so that's the end of that page. Now we're just going to look at the last page in this lesson. It's the temperature problem. So in an experiment, the temperature in a chamber is designed to change with time according to this formula. P equals 3t squared minus 18t plus 5. Now this is a quadratic formula, and it's just that the y is replaced with the p, and the t is replaced with an x. So instead of drawing like y and x, the y is replaced with a p, and the x is replaced with a t, okay? Because normally you'd see the y there and you'd see the x's here, okay? So it says, what is the initial temperature in the chamber when t is 0? So we just sub t is 0, and we get p equals 3 times 0 squared minus 18 times 0 plus 5, and we will get just 5, okay? The temperature after 2 hours, you would substitute when t is 2, you get p is, so P is the temperature, okay? So P is the temperature. You'd get 3 times 2 squared minus 18 times 2 plus 5, and whatever that works out to be, I think it's 12 minus 36 plus 5. I think that's negative 19. So I'll just check that out. 3 times 2 squared, which is 3 times 4, minus 36 plus 5. And we get minus 19, so that's the temperature. So it's minus 19 degrees Celsius. This was 5 degrees Celsius. Okay, then it says at what time does the temperature reach 0? So we sub P equals 0 and solve. So we get 0 is 3t squared minus 18t plus 5. Now look, that really looks a bit hard to factorize, okay? So we're going to solve using the quadratic formula, and instead of being x equals negative b, you do t equals negative b, because the t's are in place of where your x is normally. So negative 18 plus or minus the square root of negative 18 in brackets squared minus 4 times a times c over 2 times a. And we get that t is 18 plus or minus, now we need to work out what that is. So we've got 18 squared minus 4 times 3 times 5. So we get square root of 264 over 6. So you need to work these out. It's 18 plus the square root of 264 over 6, or 18 minus the square root of 264 over 6. And we get square root of 264 is 16.24. So we can just work those out. The first one is approximately 5.7, and the second one is about 0.29, or 0.3 seconds, I suppose, 0.3 seconds. We've got 5.7 seconds and 0.3 seconds. Now, the thing is, guys, this is a quadratic equation, and it's a parabola. And if we're going to sketch it in a minute, and you'll see why at that there are 2 times when the temperature is equal to 0, okay? Now, it says, what is the minimum temperature reached in the chamber? Now, this is a quadratic equation. It would be where the axis of symmetry is. So first you'd work out where the axis of symmetry is. X is minus b on 2a. And you get minus 18 over 2 times 3. The reason is this is a concave up parabola, and it will look like that. And so the minimum temperature will be down the bottom there. So that's why we're trying to find out where the axis of symmetry is. So we get 18 over 6. Well, I've got the minimum temperature is -3 degrees. Actually, that can't be right because we have, actually, I've made, one sec, a mistake here. That's not degrees. You know how it's x equals minus b over 2a. We get minus 18 is plus 18 on 6, which is 3. Now that's x is 3, but remember x is in place of t, so it's when t is 3, okay, where t is measured in hours. So it is when t equals 3. So now we need to work out the actual temperature when t equals 3. Let's find p, okay? So in other words, this is t is 3, not x, because we don't have x's there. So when t equals 3, let's just work out the temperature. So 3 times 3 squared minus 18 times 3 plus 5. And we get, we're just going to work that out now. So 27 minus 18 times 3 plus 5. The minimum temperature is minus 22 degrees. So therefore, minimum temp equals minus 22 degrees. And this is after 3 hours. Okay? Now, it says the experiment is terminated when the temperature reaches 45 degrees. For how long does the experiment run? So we're going to put in, we're going to substitute temperature, which is P is 45, into the equation up there. And we get 45 equals 3t squared minus 18t plus 5. And what we're going to do, we're going to take this 45 to the other side. We're going to get 3t squared minus 18t plus 5 minus 45, and that equals 0. So we've got 3t squared minus 18t minus 40 is 0. Now we're going to solve that using the quadratic formula. T is negative 18, which is positive 18, plus or minus the square root of negative 18 squared minus 4 times 3 times negative 40 over 2 times 3, which is, now we work out 18 squared. So under the square root sign, I've got the square root of 804 over 6. So 18 plus or minus, so let's do 18 plus the square root of 804, sorry. 18 plus the square root of 18 plus square root of 804 divided by 6, I get a time of 7.7 hours. And I can try the other answer, which would be 18 minus square root of 804 divided by 6. And with that one, I get a minus 1.7 hours. Now, this is impossible because you can't have negative time. So therefore, the answer is 7.7 hours is how long the experiment takes. Okay. And now, drawing a sketch showing the temperature as it varies with time. So, obviously, time has to start with 0. So it says, what is the initial temperature when time is 0? It was 5 degrees, according to part A. So when time is 0, we've got 5 degrees, okay? Then it said after 2 hours, the time was minus 19. So let's just put minus 2 hours. I'm going to put minus 19 roughly down here. So we've got this so far. Then At what times does the temperature reach 0? We had 0.39 seconds, which looks pretty good there, or 0.3 seconds. The other one was 5.7, which will be along here somewhere. I'm not going to worry about that. The next question was, what was the minimum temperature reached, and how long did it take? At what time was it reached? Well, at 3 hours, so that's not a -2, that's a +2. So at 3 hours, the temperature was -22, and that was the minimum. So therefore, that's my turning point. My turning point is 3. Sorry, you can't see any of this. So we start again. When T is 0, the temperature P was 5. When T is 2 hours, the temperature was -19. When T was 3 hours, the temperature was -22. So, and that was the minimum, so it's my turning point because the parabola here is concave up. And I'm going to put this back up here. Now we know that this point here is, it says, at what time does the temperature reach 0? This is when when the temperature is, say, 5, this is when temperature is 0 here. It occurs at approximately 0.3 hours, we said. I don't know why I wrote seconds up there, that's hours. So just fix that. And this one was approximately about 5.7 hours. Okay, so just putting them back down here. This is about 0.3 hours, the 2 times when temperature equals 0. 0.3 hours, and the other one was about 5.7 hours. Okay, and then it said how long does the experiment run for? We said 7.7 hours, and it reaches 45 degrees. So let's just put an approximation for 45 degrees up here, and that this would be at 7.7 hours. So this is the point 7.745. Okay, and that's our sketch. So we would stop it there because that's when the experiment's terminated. Okay, and that's our concave up parabola with our vertex at 3, -22. You see our minimum temperature down here is -22, and our maximum, well, this isn't a maximum, but it's when the experiment stops up there.